Welcome to the case study. So here we are here to discuss about a case study on the temperature controlling and temperature monitoring system. So before getting into the case study, let me know why this temperature monitoring is important. Where are the temperature monitoring is utilized?
To store food and beverages.
Yes, for storing food and beverages.
AC.
AC.
And to store medicines.
To store medicines, yes. So in medical field, in food processing industries and in air conditioners, so everywhere we are playing a major role in the temperature, right? So even if in a sensor there are sensors which are depending upon the temperature difference. So if the temperature varies, the resistance varies, and depending upon the resistance values, the sensor data is calculated. So everywhere this temperature is an important parameter to be monitored or to be controlled. So before getting into the program side, let me know what are the parameters we have to measure the temperature, or what are the parameters that temperature is defined.
Set point parameters.
Set point parameters.
Current temperature. Maximum temperature, minimum temperature.
Very good.
Average temperature.
Average.
Rate of temperature.
Rate of change of temperature. So these are the few parameters which we define in a program or in a calculation part, right? But basically, in a real world, the temperatures are calculated in Celsius, Fahrenheit, right? So these are the degrees, Celsius degree, Fahrenheit degree. So these are the two main things we call it in the temperature, right? Get into an hospital. The first thing is they just the temperature. What is the degree of temperature we have, right? So body temperature is the first thing which is diagnosed in a human patient. So here we are going to take in both the Celsius and Fahrenheit. So we are taking two parameters, Celsius and Fahrenheit. Now I am getting into the temperature pin. So this pin is nothing but the constant value I am getting from the external world, the analog pin. So in a microprocessor there are 40 pins. So in the 40 pins I am taking the 39th pin for this temperature pin. So from the external data, I am fetching the temperature. I am going to give the temperature to the pin number 39. So you can choose your pin up to you. I am just choosing one port. I am choosing the one pin. Now I am going to initialize a value. This value is nothing but the value I am going to fetch from the real world data. I am going to use an int value. Double I am taking because I am going to convert it into a Celsius, Fahrenheit and millivolts. So these data will be in a decimal values, right? In a point. So if it is in a point, we can take it as either float or in a double. So we just initializing these variables. And next I am going to write a program. Here I am going to start with the serial begin with the baud rate of 9600. As you know, the baud rate is nothing but the rate of transmission of a data. So the rate of speed of transmission of a data. In a loop, I am going to add a few instructions like value. So this value is nothing but analog read from the temperature pin. So from the 39th pin, I am going to read the temperature from the real world. So through this 39, I get a real world analog data. That analog data will be stored in my value variable. Okay. Next, for the millivolt, I am going to convert this value into a voltage value. That is in a millivolts. So for the conversion, I am taking this millivolt variable is equal to value, that is real world value, divided by 2048 into 33,000. So I am going to convert into the millivolts. Next, after that, I have to convert into Celsius and Fahrenheit, right? So I am taking two parameters. In Celsius, I am going to convert this millivolt into 0.1. For Fahrenheit, I am going to convert this Celsius with respect to into 1.8 plus 32. So I am getting the value from the real world, converting into millivolt, and I am converting this millivolt into Celsius degree. And after converting into Celsius, again I am going to convert into Fahrenheit. So now I have to display it, right? Somewhere I have to know the value. So I am getting into serial pin. First, temperature in Celsius. So Celsius value will be displayed, and for the next line I am going to give it into C. That is indication of the Celsius. So first I get temperature in Celsius will be equal to, for example, 0.11 into C. This is the notation for purpose of notation. Next, serial print. Next line, I'm going to temperature in Fahrenheit. So temperature in Fahrenheit equal to, I'm going to call this function. So value will be displayed. For example, 1.21 into F. That is your representation. So finally, delay 2000. That is for every 2 seconds, your temperature will be monitored. So any doubts in this program?
That 2048 is a PID controller.
No, it depends upon my not controller. It's a conversion to the real world data. So that is millivolt. For voltage, I can take it as 2. For conversion of millivolt, I am taking the real world time representations. And this one is also you can you have found it in physics. Like into 1.8 and that calculation will be 2 Fahrenheit. Plus 32 is your degree conversion. That is room temperature. That is degree conversions. So any doubt on this? Can you brush up on this? And before getting into the brush up section, can anyone tell me the flow or that block diagram, like how your temperature may be observed from the real world? So what are the components required here for a temperature monitoring? Sensor. So I am taking LM sensor. LM375, whatever the series you can take. And with the help of sensor, I get the reading. So after getting the reading, what I should do? Okay, who is going to get the data? A processor, right? A processor should have a sensor. This sensor value will be given to my processor. What this processor will do, fetching the data, does all the calculation and conversions and gives my output. So here my processor will do all these conversions and gives the output in the required serial monitor or whatever the display unit you will be using. Okay. So this very simple case study. And can you give me one applications or examples like where you can use this program to monitor the temperature? It's in fever, but you're just measuring and just you're monitoring. Any other applications? Microwave, okay, good. You're just capturing the input temperature and you're going to display it. Very good. Next. Simply your air conditioner. It observes your temperature and displays, right? What is the room temperature now? What temperature you have set it? It displays the temperature, right? So we are getting the display of only the value, but we can add it to the preference. What are the preference you need? You can add to your preference. Okay. So in next series we will discuss about the other applications and other control systems.